Hello guys, I finally have a new VDTC update for you. As you can see, a lot of things changed. First of all, the power supply has been completely rebuilt, and I'm using higher spec diodes with an individual RF bypass. It's classic 2 mods in series, and this is the doubler capacitor. This is 3 microfarads actually because there are 2 banks in series, so it cuts the capacitance in half. This we still have the RF choke here, and but I guess the most drastic change is that I hooked up the vacuum capacitor, and it's adjustable, right? So I can get it perfectly in tune, and you will see the performance difference I got later. But we also have the change in the grid leak. I'm no longer using 2 light bulbs because they like to just destroy themselves because of the setup here. Because basically there's a high RF potential all around the light bulbs. So if there was gas ionization to happen, one lamp would get gas ionization, the other one would just instantly blow and would blow the other one too. So like if one blows, the other one also blows. I tried to combat this with a fuse, but it wasn't much help. But I still have a fuse here just in case there's some kind of arc over. And yeah, so because I don't have the bulbs anymore, I'm using a small current meter to measure the grid current. This is actually adjusted for 600 milliamperes full deflection. Okay, we still have the volt and amp meter here. The volt and amp meter have been bit, I guess you can say, recalibrated. The voltmeter is now like completely accurate, and the amp meter has an RF bypass capacitor on it just in case, but it didn't make any difference, so I guess I was fine to begin with. You also see here this insulator that I've made. This is from I think you put like drill bits inside of there or like something, and this is actually adjustable. I have it on the maximum setting to provide maximum clearance because this is metal, so it could and because you can arc over from here to there, you can also arc over from there to there because this is basically right across the primary, so you want as much voltage isolation as possible. Yeah, I guess that's most of the change. The power supply is like, more clean. You see the wires are more organized. I guess I need to put some electric tape over the switch so you don't electrocute yourself. But I also made a test of power factor correction. I still need to do more testing right now, just all the capacitors hooked up, so it might actually be a bit overcompensated now, but for a short test it doesn't make much difference. This cooling fan still works. I removed this cooling fan because it could interfere with the arc and it's not necessary. So let's cut a bit of power consumption down, but just removing power from one cooling fan. Yeah, that's pretty much most of it. The primary is the same, the secondary is the same. Um, yeah, that's the schematic there, but I'm gonna put it on a community post so you can get the high resolution version. So yeah, the capacitor is adjusted to around 51 picofarads, if I remember correctly, 51, 52 picofarads. The resistance is around 320 ohms. So I guess we can fire it up so I can also show you the starting sequence. So first of all, I enable the cooling fan with that switch. The fan is operating, I'm not sure if you can hear it. Then I check if the primary and secondary are perfectly, if the distance is like perfectly right, so it's like centered. After that, we turn the filament on. You can see it's starting to glow. So yeah, just a bit over 12.6. So when the mains voltage drops a bit, it automatically corrects itself to 12.6 volts. All right, we do a last minute check if everything is all right. Okay, now we check if the auto transformer is to 0 because there's a switch in there that enables a soft start. I guess we can enable the ammeter to see how much it draws. All right, everything is okay, and we turn the B plus switch on. It only gives power to the variac and doesn't give full mains voltage or not, so this is still a kind of safety touch. All right, so we disable the lights. I have this emergency light there, so if if my breaker was a trip, I would not have to be here in the dark. So I will clip my phone now into the phone holder, or whatever you want to call it. All right. Okay, we're ready for testing. Okay, so let me. Okay, so we're ready. So the variac is right now on 0, and now we turn it up. 1 kV, 2 kV already, voltage, and we have breakout at around 150 volts. The current draw from mains is 6.2 amps. And that's the maximum. Drew around 17 amps, and there was some slight, you can hear some corona or like tiny bit of arc over. But so yeah, some fine tuning is still needed. From what I saw, the anode current was around 0.35 amps, the grid current was around 0.2 amps, and the secondary current was around 3 amps. So yeah, I think this Tesla coil is working pretty good. There's obviously some tuning still needing to be done. Right now, it's actually the best I've ever gotten it, and the tube probably red plates after a long while of operation, but it will probably, my brain's breaker will probably trip before the tube completely red plates. So let's enjoy it a second time. Damn, that's nice. All right. So, okay, yeah, with that, I guess you can wait for the next update. I will make a community post soon, and with the schematic and I guess some other stuff that I found out. Yeah, this is the setup again from this angle, from the front. Let me disable the B plus just in case I don't want to electrocute myself. Right. This is it from the side. Right. Yeah. It's also important that the choke is like 90 degrees rotated from the secondary. Oh, you can see it was a bit off center. That's why it was probably arcing a bit. Yeah, I guess that's better. I mean, we all make some mistakes, but the thing is, since this tank is DC isolated, because of this blocking capacitor right there, we won't get a catastrophic arc over, as you could hear. So yeah, the only thing that could happen is for the oscillation to briefly stop and then kind of fixes itself. Yeah, so this wire here is just for shorting out the capacitors. I mean, the tube discharges them, but you know, it's always safe to discharge them before you go touching stuff. Of course, I'm a wonderful example of this. You don't want to follow my advice always, but yeah. So yeah, the cooling fan needs to remain on. I'm gonna slowly turn the tube off. It's also nice to have the tube filament under a small auto transformer, variable auto transformer, since you can perfectly soft start it every single time. Yeah, and I'll plug it from the mains. The variable auto transformer can also be unplugged. The cooling fan can stay on. So as you can see, I have the filament, B+, and the cooling fan on different circuits. It's actually missing from the schematic. I will add the cooling fan. Yeah, not that much actually to say. On the current draw, it maxes out the meter, so yeah, I guess I need to experiment with the power factor correction, but I'm not sure if there's much to be done. I think it actually lowered the current draw a bit, and I'm actually overcompensated now. So yeah, I guess that's a goodbye. It's almost 3 in the morning, so I also want to go to sleep because I have to wake up a bit early. You know, I spent an hour working on the schematic just for my loyal viewers here, and for me in the future. So yeah, I'm not sure if there's much to say. I mean, okay, I guess we can go over a little bit of the circuit. Um, it's a fairly standard Hartley oscillator and it looks really complicated, but that's because this is a because there's a lot of extra components, like for example the ammeter and all that stuff. This is a traditional grid link again. This is just an RF choke here because it can theoretically oscillate through the grid to anode capacitance, as you can see. And this choke usually is enough. For me, it slightly wasn't, so I added a second one there, just in case it doesn't hurt, because it can probably oscillate through ground and some other bullshit, because it can oscillate through ground, through the cap, whatever. Even though the choke should stop it, whatever. Parasitics everywhere. So yeah, over here, the 590 picofarad 30 kV capacitor across each diode. All of them are in series, and you can see how they are arranged. So yeah, and it's important to clip on the B plus connection, to clip them on close to the capacitor and not to the diodes, because you want this capacitor to bypass all the RF. You want this to short the RF, and you don't want a shorter connection to the diodes, because the capacitor might be far enough away where the RF passes through the diodes and not through the capacitor. The filament RF bypass is also needed. I have a dual bypass system from the filament ends to the center and across the filament ends. That's the best way of doing it. The tube is configured in triode mode. You see all the grids together. I also have a protective spark cap here, so just in case that there's any overvoltage, it doesn't short inside of the tube or whatever. I might give it a go with grid 3 to ground, even though the grid current seems to be really low, and it might benefit from the third grid to ground to remove the secondary emitted electrons, to yeet them back onto the anode. But I still need to do some experimentation with that. Otherwise, it's fairly standard, I think. I mean, it's a high frequency, so you get obviously more mistuning from parasitic components, and the special stuff is that the Tesla coil here, its resonant frequency is really high. It's high, but it like drops down way lower than you want it to. It drops by like almost 1 megahertz. Well, almost half a megahertz or so, a bit more than half a megahertz. The original one is 2.2, and it drops to 1.6. Even with the top load, it wasn't of much use. I didn't get any breakout. I only got breakout after a bit half variac, which means that okay, how can I say this? Because the resonance frequency is high when it's unloaded, so without an arc, it's basically out of tune, so it doesn't produce breakout until even the voltage that is still inducing it, because it's still a resonant circuit and the resonance frequencies are kind of close, only 1 megahertz apart, or half a megahertz apart. There still is some RF voltage being induced onto the secondary tank, and that causes a breakout, and the breakout causes it to rise further up to the power limit, as close to the resonant frequency as possible. And when you provide more power, it can get close and close in tune. You might have seen that on video, because the arcs certainly behaved more. You can hear that the arcs got less chaotic in sound, at least. So yeah, that's pretty much it. The tube should have cooled down enough where we can turn off the cooling fan. It's always good to have the cooling fan positioned in such a way that it blows air over the top connections. You generally don't need to cool the bottom connections, but that's also a good idea. But the top connections experience the most thermal stress because of the hot anode, and the heat rises, of course. The tube is cool enough to touch now. It's just barely warm, and that's fine. Important note, you have to keep the wires with high potentials far apart. For example, we have the ground, over here we have the 8 kilovolts, and you can see I've put a piece of tape here to permanently isolate them. Otherwise, we could get an arc over between this and this wire. This isolation distance is fine. And over here, that's the feedback. That's the ground, and that's the extra wire is of course the feedback. And I have just a bit of wasted plastic over there to isolate the wires from each other to stop them from touching. This is the vacuum capacitor holder, and these are the terminal connections for it. This radio knob is from the 20s, and this plastic part was printed, not printed, it's actually a CNC machined at my father's work. And yeah, so these two components have 100 years difference in them, because this is from 2025 and this is from the 1920s. So yeah, not much else to say. Of course, because the resonant frequency is high, it can make more RF interference. For example, I had a problem where my internet used to crash, and I fixed that by putting some aluminium foil there to basically ground out the RF being induced onto this Ethernet wire. But the soldering station also basically turns itself off by the interference, and the power supplies, etc. If you have them on, they might not like that. So you want to keep sensitive electronics away. I also don't have my phone charger plugged in anymore, because you know you don't want your phone to be charging next to this, because it might break the charger and you blast your phone with high voltage spike. So yeah, be careful with high voltage. Educate yourself. Start small, etc. Yeah, and I just turned off the meter, and it's almost 3 in the morning, so I will head off now. Thanks for watching.